Thanks, Ravi and Pawan for wonderful presentation. Now I welcome Mr. Rajeev Joshi from Yokogawa. His presentation title is Industrial AI from Automation to Autonomy.
Good afternoon, everyone. And as earlier speaker spoke about, it's afternoon. And after lunch, I think most of us may be feeling require the nap, right? And me too. But whereas the AI doesn't require the nap, correct? And how many of you knows the Jay Advani? Anybody from here from the PwC? I have nothing to do with this presentation. I'm just asking. Anybody is from the PwC here? Okay, no problem. He is a managing director of PwC, and he writes very interesting articles in the LinkedIn. Some of them I will want to quote here because it all related to each other. So he writes like, Jai requires the chai break, but AI doesn't. Luckily, his name is Jai. If you remove J, it becomes the AI, right? So AI is like that now. It doesn't require any kind of rest. It will run continuously. It will help for the productivity improvement and all. Okay, let us see that one, how it is adding value in terms of Yokogawa also, how Yokogawa is going to help for the AI journey for our customers, okay? Before we start this one, I want to introduce myself also here. First of all, thanks ARC for this forum, and thanks to Yokogawa also. Myself is Rajeev. I'm working for Yokogawa from last 25 years. I've been working for the industrial automation and also a part of the large project delivery in Yokogawa. My doctoral research is also associated with the digital strategy and the digital transformation. In next 20 minutes, we will go through what is autonomy and autonomous means, and what exactly the value it brings to the industries. And also I will be going through the 2 industry cases where Yokogawa has implemented the AI agents, and we have demonstrated that it can be implemented very responsibly. So that we will see those 2 cases also here. And when it comes to Yokogawa, I think most of you may be knowing it already. I will take only few seconds to introduce Yokogawa here. It was established in 1915 by Dr. Tamasuke Yokogawa. And we have been in the measurement and control field from last 1 century. And Centum has been a part of our journey since 1975. With the Centum as a foundation, we have extended our services to for the safety system, as well as the APC advanced process control, plant asset management, and digital twins, OT-IT integration, and all those fields. And when I'm talking about the AI, why all these things matters? Because industrial autonomy cannot be built only by using the AI models. That is not possible. Actually, it has to evolve from the measurement and control, because I'm talking here mainly with respect to the control systems, which is the core of the industries here. So it has to evolve from the measurement. It has to understand the process behavior, and mainly it has to coexist with the existing control system. It has to work along with that within the safety limits. That is why all these things matters here. Okay. And when it comes to our India operations, we are having 17 sales operations, and we are having the 3 engineering facilities. We are also present in our neighboring countries like Bangladesh, Sri Lanka, and Nepal. Of course, throughout the world, we are having the offices more than 70 countries. But when it comes to India and neighboring countries where India is operating, so this is our presence. With this presence, we are able to translate our global experience to meet the local Indian realities. That is how we have been operating and trying to give the values to the Indian customers also. So now coming to AI, which is a core of the discussion here. One is the normal AI, which I think all of us have started using it, right? When it comes to the AI, immediately come to in our mind is, one is, I can say chatbot. And then we are using the generative AIs, LLMs. Most of us here are actually already using it for the drafting the email, definitely, right? And some of us, sorry. Sorry about that. And we are also started using it for creating the minutes of meeting using the Copilot and all. Some of us may be even using it for the data analytics and project management, right? But when it comes to the plant, it has a very different role to play. When I am using it in the office environment, there is a chance that I can do mistakes, I can go back and then I can see whether it has done the right work or not. But in industry, it should be very deterministic, right? It has to be very precise. And moreover, it has to work along with the operator and it has to work in the safety limits. That is why the industry AI is very much important. It is not just an algorithm that will work here. It has to actually work along with the existing control system. It has to work with the data and it has to work with the operational requirement. That is why industrial AI is very much important for us. So why we are actually now going for the industrial AI? Why the industries has to adopt the AI is a core question, because we are facing a lot of challenges. As you can see, there is a supply chain issue, there is a changing workforce issues are there, sustainability, and mostly you can also, I think most of us have suffered during the COVID-19 also, right? Even though now there is no COVID-19 is there, but we should be ready for such kind of pandemics if it happens. So plants should be resilient enough to run, even though there is a human resource of the supply chain, constraints are there. For all these things, we have to be ready, and AI is going to do some kind of support here. That is why we all are looking for it. Now coming to the core of the control system here, how AI is going to help. So we mostly, whoever is coming from the industry or the process control background, we will be knowing that most of the work is already being automated, and we have been using either PID or the APC controllers, because the most of the things are being done by PID itself, and APC is giving the even the advanced or the complex control capability. But there are still multivariable processes or the non-linear processes where PID as well as the APC is not enough for the controlling. That is where the industrial agents comes into the picture. We are trying to minimize that gap using the industrial agents here. We will see how we are going to handle those things in the next slides. So when it comes to the Yokogawa, we are not just having the one product here for the AI, because AI cannot be achieved, or the industrial AI, we cannot get the benefit by just one product. We are having the bunch of services which we are providing here, like IA to IA, OPEX, and we are also having the AI-equipped recorders here, and there is AI analysis software that is also a part of our solution. And moreover, we are also having the FKDPP and the Smart Python Industrial AI platform. So these are some of the solutions. I will be visiting some of them now in the next slides. Before that, I want to play one video. Yeah, thank you.
Are more complex than ever. Volatile demand, evolving regulations, sustainability challenges, and an increasing need for resilience. Industrial automation today operates on robust control foundations that power critical operations across industries. Together, these capabilities form the foundation of modern industrial performance. However, as industrial environments grow more complex, with greater scale, variability, and faster decision cycles, the demands on these systems continue to increase. Operations today must respond to changing conditions in real time, often beyond the limits of manual supervision alone. This is where autonomous operations emerge. Autonomous operations empower industrial plants to run, learn, adapt, and thrive in tomorrow's operating environment. In autonomous operations, systems are designed to learn and adapt, enabling them to respond intelligently, even to situations that were never anticipated. This structured progression toward autonomy is what Yokogawa defines as IA to IA, industrial automation to industrial autonomy. It is a phased pathway where intelligence is progressively introduced into existing automation systems, enabling organizations to evolve toward autonomy without disrupting the control foundations they rely on. In a rapidly changing world, industries need agility. Yokogawa's IA to IA enables autonomous operations, efficiency, and reliability. It empowers people, ensures safety, eliminates downtime, and optimizes supply chains. With self-learning systems, it also accelerates sustainability and the circular economy. Within the IA2IA framework, organizations progress through clearly defined autonomy levels on the journey to autonomous operations. From manual and semi-automated operations to automated and semi-autonomous systems, where humans and intelligent systems work together. And ultimately, to autonomous orchestration and autonomous operations, where facilities operate with increasing intelligence and minimal human intervention. At advanced stages of the IA2IA maturity pathway, autonomy enables systems to continuously adapt to changing conditions. This is autonomy in action, intelligence enhancing existing automation systems. The future of industry lies in structured autonomy, and IA2IA provides the pathway forward.
Okay. Well, that brings us to what is the vision of the AI from the Yokogawa side. We have a very clear vision about the AI. The aim is not to make artificial intelligence a competitor to the human. We actually want the artificial intelligence co-pilot for the operator, not to replace him. And our idea is to pursue the present, predict the future, and optimize the operation. That is what we are looking from the AI. Okay, and coming to IA to IA, which is industrial automation to industrial autonomous. It is built with the purpose of achieving the smart manufacturing goals. In terms of Yokogawa, the definition is like plant asset operations have a learning and adaptive capabilities that allows the response with minimal human interaction, which will empower the human to perform the high-level optimization. It doesn't mean that we are trying to reduce the human involvement here. What we are trying is we are actually relieving him from the repeated work, and we are trying to utilize him for the high-value added assignments. Okay, so that is what is the again continuation of the automation and the autonomous here. So, what is the difference between the automation and the autonomous is the question. Because most of us know that a majority of the activities are being done in the plant using the automation itself. So what is the difference now between both of them? How automation works is like it is having the predefined logics, right? We have built the logic either in the PLC or in the DCS. There is a set of logics already there in the system, and it is going to run accordingly. But when it comes to the autonomous, what happens is if there is a sequence of events, after each sequence, when the sequence completes or maybe the sequence is interrupted, that time operator has to interrupt and he has to take some actions. But whereas in the autonomy, what happens is system will be taking care of all this, and it will minimize the intervention of the human, because that itself, based on the historical data and how the AI model is being built, it is going to take care of those actions so that his intervention is minimized. That is what we are trying to achieve using the autonomous systems here. So it is a phased manner that I have shown in the YouTube video also, you might have already seen. We are not just jumping from the automation to autonomous here. It is a very deliberately phased manner. We start with the semi-automated and then go for the automated, semi-autonomous, autonomous orchestration, autonomous operations. Each phase has the definite value to the customer. In each phase, we are trying to achieve certain things, show the outcomes, and then move forward to the next phase. That is our intention here. And as I told, industrial AI or the AI algorithm is not just sufficient. It has to work with the integrated system, which I have shown here. Like we should have the first thing is the data. We should have the smart sensors. We should have the IoTs. And then we should have the edge cloud. We should have the DCS SCADA integration. And more importantly, the workforce. Because when we are deploying AI agents in the plant, the workforce should be good enough. They should have the knowledge of what actually we are doing. Then only we can utilize. So that workforce upskilling is also most important here. So this is all part of the Yokogawa system that we are planning. So this we are using it through the OPEREX systems. OPEREX system is a brand that stands for the excellence in technology. And with this, we are providing the integrated solutions that will combine measurement, control, as well as consulting, execution. Everything is being combined, and we are providing it as a solution to our customer. And when it comes to the AI in the autonomous, the core of thing for the Yokogawa is the FKDPP. What is FKDPP? It is a factorial kernel dynamic policy programming. This is actually nothing but a reinforcement learning model, okay? And it was jointly developed by Yokogawa headquarters, which is in Tokyo, and Nara Institute of Technology. In fact, it was published in IEEE in 2018 itself, and it is also patented. It is considered as the world first reinforcement learning algorithm. Now, there may be some other models might have been developed, but in 2018, when it was developed, it is considered as the world first reinforcement model, which is used in the industrial plant. The general algorithm are there, but with respect to industrial plant, it was the first algorithm. And how it works is, it is mainly used for the multivariable complexity. As I told, we are still going to use the control system, existing PID controllers of the APCs. This one is useful when we are having the multivariable complexity. And how it works is, it is a self-adapt, it is a self-learning, and also it will rapidly deploy the solutions whenever there is a change in the process variations. That is how it works actually. So benefits are listed here. It is unified optimization and control, real-time adaptability, superior performance. That we'll see actually when we come to the industry case where it is being deployed. So this is one of the first industrial AI agent where Yokogawa deployed it. It is in the Japan, Inos Material Chemical Plant. This is where Yokogawa and Inos Chemical Plant together work, and we developed this model specifically for this chemical plant. And how we worked is like initially the model was developed in the Yokogawa office. After that, it was tested in the simulation mode, and then we deployed it. When we selected, it was not that the whole plant was selected. We selected only a small portion of the plant, which was very critical, and there was a lot of manual operation in that, where I've listed here that the manual valve, which was very critical, the operator judgment was required 24/7. So we selected that, and then we actually did the simulation. After that, we deployed it. And the point is not that AI agent worked during the demonstration. Actually, even after the demonstration of the successful demonstration, it was adopted in the continuous plant, and the success was visible to them. And the second case where it is being recently done, in 2025 October, this is being almost implemented, which is in the Aramco Fadhili gas plant. Okay, so in the Fadhili gas plant also, we did not rush to directly implement the AI agent. It was again a phased manner. This is actually implemented for the acid gas removal unit there. Okay, so we started with collecting the data, the historical data, and then we trained the FKDPP for the AGR process, and then there was a simulation. After that, we started with the non-critical sub-process first, and we developed the operator confidence, because that is most important. When we are doing such kind of experimentation, first the operator, maintenance team, all those people should have the trust, then only we can go for it. So we developed the trust. After that only we deployed it. The early results are really exciting one. You can see that there is a 10 to 15% reduction in the amine stream. There is a 5% reduction in the power consumptions, and there is an improvement in the process stability and the significant decrease in the operator manual intervention. Of course, these all points are very much important, but even then the more important point here is the strategic vision of this, because once we are successful in this, we have done it recently, as I told, October, November only, and then it can be deployed to the other part of the plant also, and we can go for the large scale development. That is most important here, okay? So now when it comes to other units, it is not just that we can deploy it for the oil and gas or chemicals. We are also working with the shells for the robotic inspection. We are also working with the uptime for the asset health, and for the Rolls-Royce also we are working for it, okay? And now the question comes how it is relevant to India operations, right? Because India is having different demographic. we are already having the lot of resources. There is no scarcity of the resource, whereas the other part of the world is facing the resource problem, but we are having still abundant young resources are there. But still what we need to know is we are having the large number of young resources. They doesn't have the full experience. That is where the AI come into the picture, because if we are having the co-pilot of the AI, how we can do is even we can have a 4 to 5 years of experience operator or the engineer, and he can be supported with the knowledge that is being imparted by 15 to 20 years of the operator or the engineer. That is how we are thinking about using the co-pilot and the less experienced engineer working together to deliver the value to the customers, right? And of course, India's PAT performance achieved trade scheme creates direct financial incentives for the industries. So anything we can save in the energy, that will be beneficial. And of course, the ESC, which is a carbon monitoring system, which is going to be one more benefit for the Indian operations. And we are also going with the large scale smart cities. There also AI is going to support. And these are the areas where definitely Yokogawa can support. And when it comes to the approach, how we should go, I propose actually, again, 3 phases here: assess, pilot, and the scale. Don't start with the question that how AI is, where I can use the AI, then that is not going to help. Because if you start thinking, then we will end up nowhere, right? Instead of thinking where I should use the AI, think of what is the problem I am facing with respect to the process, and is it having the more value, and how the AI is going to solve this problem. If you go with that approach, definitely we can deploy the AI and start getting the benefits out of that. So before closing, I would want to say that now the industry is having a lot of data, but that data is not being utilized properly. So the winner of the next industrial era is not who is having the most data, but who can transform those data into the autonomous outcomes. That is more important. Let us utilize those data and try to have the benefit to the industries. So before closing, I want to give one message. The Aramco, in both the cases, Yokogawa implemented this solution. They did not wait for the perfect solutions, right? They actually selected critical problems. They did the pilot, and they got the confidence, and then they deployed. So the question is not whether this AI, industrial AI is going to affect, or the autonomous AI is going to affect the industries or not. The most important thing is how fast we move and get the benefit out of it. So let us move and work together. Yokogawa wants to do co-innovate with all of with our customers. Let us work together and provide the business outcomes to our customer. That is our intention. Thank you.